and welcome to this webinar proudly presented by Murata and his partners. My name is Gonzag, and I will be your host today. Firstly, to ensure that you are tuned into the webinar, please connect your computer's audio with Zoom. Next, for everyone to have an optimum experience, attendees will be kept on mute. If you have any questions at any time during the webinar, please feel free to post it in the question and answer panel located at the bottom of your screen. Questions will be picked up and answered during the Q&A session at the end of the webinar. Last but not least, material presented will be made available after the session. Today, we will explain about non-terrestrial network over NB-IoT technology to keep IoT devices connected beyond borders. I would like to take this opportunity to thank our valuable partners, Skylo, Monogoto, and Enritsu, who are joining the webinar today. Let me briefly introduce today's presenters and panelists. Myself, Gonzag, in charge of product marketing for Murata wireless connectivity module in South Asia and Oceania region. I'm based in Singapore. Voon Yen Liu, field marketing manager at Enritsu, also based in Singapore. Mao Efrati, CTO and co-founder of Monogoto, based in the US. And Skylo, and from Skylo, Setander Yadav, director of sales engineering, based in India. Now, I would like to briefly explain about the NTN ecosystem. There are actually three important pillars: the wireless communication modules, the network, and the testing and compliance equipment. Firstly, Murata's integrated wireless communication module can bring cellular plus NTN connectivity to your IoT device, allowing it to send and receive data to global cellular network as well as Skylo's NTN satellites. Then Skylo, a leading satellite NTN service provider, and Monogoto, an IoT connectivity management platform provider, can offer seamless connectivity to scale up the deployment of your fleet of smart devices around the world. And finally, Enritsu, who supplies test and measurement equipment to be able to validate the performance and ensure compliance with each market telecom regulations. This is today's agenda. Firstly, we'll introduce a Skylo NTN network and services in Australia and New Zealand, and the plan for APAC. Then we'll explain more about Murata integrated cellular plus NTN hybrid modules, how to test it with Monogoto SIM card and the connectivity data plans available, followed by a couple of technical demos done by Murata and Enritsu. Finally, we'll move to the Q&A session in the last 15 minutes. You are welcome to post questions anytime during the presentation, and we try to answer it at the end. Now, I would like to pass it on to Setander, our first presenter, to explain more about Skylo NTN network and services. Setander, over to you.
Thank you, Gonzag. Good morning, good afternoon, everyone. Let me Can anyone confirm if my screen is visible?
It's okay, we can see it, Setander.
Okay. So as I said, good morning, good afternoon, and good evening, everyone. Welcome to the webinar. Before I get into talk about Skylo, I wanted to basically talk about why we are doing this, like why everyone is talking about NTN in this current schema of applications. If you look at the world we live in today, the world is changing every day, and the continuous connectivity's demand is actually increasing day by day, right? And the existing technologies what we have today, be it cellular technologies or private networks, cannot cover the entire globe, right? And also the traditional satellite networks what we have, they don't basically play along with the existing standard-based cellular network. They need to have a dedicated proprietary hardware and protocols, and that's where that's where we basically wanted to understand or basically bring in the concept of NTN, which is standard-based solution. And the way IoT technologies are increasing, multiple things are happening. One, the standardization of NTN solutions are coming up now. multi-technology or multi-orbit solutions are coming up. We are talking about GEO, LEO orbits. And obviously, standard satellite NTN solutions are basically integrated with 5G solutions, right? And that's where I want to involve Skylo. Skylo is basically, if you look at it, we play a two role in this. One is obviously we are a satellite network operator, but we also are a technology orchestrator. If you look at it from the perspective of what we do today, we are a part of a GSMA and we are also a member of an ITU. We have our own PLM and IDs. We run our own RAN network. We do have our own core. And if you look at it from the perspective of what we do, we basically serve two use cases. One is the consumer and IoT, right? Consumer use cases are totally different from IoT. They need, and the devices are totally different. We are looking at smartphone and wearables devices. But if it's IoT, it's a totally different where you're looking at devices which are sending mission critical data with a very low frequency and very low throughput on data on that, right? We are licensed about 30 plus countries, and we have coverage over North America, Europe, Australia, New Zealand, Japan. I can get into coverage later on, but the intent is to basically go global in a year or so. The business model is like we work with MVNOs and MNOs, and we have one of our MVNO partner on this webinar already, Monogoto. We basically act as a wholesale network for our partners, where they basically intend to converge or basically sell the plans of cellular and satellite together for the end customers, right? As I mentioned, we already have coverage over 4 continents and all. Let me go to the next slide. And as I mentioned that we can connect any devices, be it consumer and IoT, anywhere without having to change the hardware, without having to change the existing relationship what you already have with your carrier partner, and without needing of an extra hardware, right? The switching between satellite and cellular is so seamless that you won't even realize that you are basically going out of network coverage today. You can have multiple use cases, but as you mentioned that for consumer and IoT use cases differ. For consumer, you have two-way messaging. You can have SOS alerts sending out from a mobile phone or for a wearable. But from an IoT, you can have all kind of mission critical data sent from point A to point B today. We basically connect with our MVNO partners or MNO partners with a very standard 3GPP interfaces. We don't need any kind of an external or proprietary kind of interfaces to connect with any kind of providers today. If you look at the application, what we serve today, as I mentioned, smartphone is one of the leading use cases, and we are getting a lot of traction from consumer use cases. But connected cars and automotive is also one of the leading use cases which we think and which we believe that will benefit from NTN technology and convergence of cellular and satellite. IoT is always one of the biggest enabler and one of the biggest demand creator for NTN. But if I look at IoT use cases, if I can dig down multiple into terms of how the IoT applications will be benefited, we think these are the most suitable use cases for NTN, where we're talking about pipeline monitoring, remote agriculture, remote energy monitoring, maritime, automotive. But feel free, like in fact, one of the major use cases which even I was not aware of is cattle tracking, which is getting a lot of traction on NTN, and we realize that I'm amazed to see the kind of use cases which our customers and partners bringing on the table. And we are glad to basically support them in terms of connecting those devices which are remote and which never have ever seen that kind of connectivity with the same devices, same SIM card, and same kind of ease to connect. Just to get into basic highlight of what networks look like. We are a standard-based 3GPP network based on release 17. We work on LNS band, which is a mobile spectrum satellite bands, band 223, 255, and 256. We support IP and non-IP traffic both. But in IP, we always prefer to have UDP because UDP has its less headers, and since it's a packet-based non-streaming data, it's a NB-IoT data. We always prefer to have a UDP data over TCP. The maximum size or MTU of a packet which can go up to is 256 bytes. We are trying to expand more, but this is what we have today. And the medium latency, what we're looking is around 10 seconds because these are geostationary satellites. And to close the link from the UV to the satellite and go back to the your server, it takes around 10 seconds to and fro. We do support power saving modes like PSM and EDRX already supported on this network. The basic thing what we're looking at is like if you want to connect our devices to our network, first, the device has to be certified on our Skylo network, same as it is, which is happening today. Like if you want to connect our devices to a cellular partner or network, you have to certify your devices to make sure that that device is already certified and meeting to a minimum performance criteria. But typically, if you look at how do we certify devices, they are certified in type A and type B, or type 1 or type 2. Type 1 and type 2 are nothing else, but it's just the characteristics of how an RF performance is behaving on the device side. The second part is it should have a GNSS, because to close the link, we need to know the exact location of the device. It's a geostationary satellite, so we need to close the link also on that. And one of the advantages what we say is that it's a standard LTE antenna. You don't have to make a custom-based antenna or anything of that sort. You should have an NTN capable SIM card. It can be from our MNO partners and VNO partners, and obviously an NTN subscription on top of that. One of the major requirements what we think is, what we believe it should have is the device should have an ideal line of sight to the satellite. If these three things are met, I think you should be able to connect the devices as seamlessly, as easy, the way you connect your cellular satellite today, cellular devices today, right? But as I mentioned about the devices has to be certified, I wanted to just deep down in terms of what Skylo certification program looks like. See, it's in our vested interest to make sure that devices perform a minimum kind of a device performance on network. And for doing that, we basically have certification programs at 3 different levels. One is at the chipset level, modules, and the obviously end devices level. Chipsets level requires a lot of effort because it needs implementation of NTN capabilities, NTN protocols on the chipset level. This typically goes around for maybe 8 to 12 weeks. But once you have a chipset certified with Skylo, and if you're building a module on top of that, basically we look at RF front end and everything. This takes around 2 to 4 weeks. And once you have a module certified already, and if you want to build a device using a certified module, I think we certify and do some spot checks, and it takes around 2 to 3 weeks to certify a device also. But today, what we have done is we have also enabled third-party labs to basically perform the certification on behalf of Skylo. And if you can reach out to Skylo.tech partners webpage, you can see we already have listed down the third-party labs. You can reach out to them, perform the test, and give us the report. We will perform spot check and certify a device for you. Now, one of the major thing which is asked to us is the coverage part. As I mentioned, we already covered North America, CONUS part. We cover most part of Europe today. We cover Australia, New Zealand, Japan. We also have coverage over Taiwan. But if you look at the roadmap which you're talking about, we are going to cover Southeast Asia sooner or later. And LATAM is something which you're looking at next now. But technically, if you look at, and if you ask me, can we provide coverage today in any part of the globe? Yes, we can. It's not a function of technological challenge, it's a function of demand. So if we receive a demand from a specific geography, and if we think that the use case is making sense for us, we will prioritize that particular geography, and we will open that network for you. One of the advantages what we have today is that we don't have to worry about spectrum. We leverage the existing spectrum, what we already have it from the geo satellite partners. The only thing what we need is the regulatory approval for an operator license. So we can basically scale this network to global coverage as soon as possible. It is not a matter of technology challenges, it's a matter of global demand, what we're looking at right now. And on that note, I think I just wanted to show you exactly what is the smallest device and how can we basically connect a device to satellite. This is off-the-shelf device, which we got it. We just powered it off, make sure that this device is updated to the latest firmware for NTN capable. This has got an existing or basically internal GNSS and an internal antenna, and this was connected to our Skylo NTN network. We drove from Mountain View to Monterey. I don't know how many people are familiar with that, but if you look at the road from Mountain View to Monterey, it's basically a huge forest where you can't see the straight sky also, but we managed to connect it. We never lost any kind of data here. And I think we have a use case already published on our website. People can go and view the result there itself. On that note, I'm going to hand it over back to Gonzag and happy to answer if you have any questions. Thank you, everyone.
Thank you, Saitender. So a quick introduction of Murata. It's a global leader in manufacturing electronic components and modules since 1944. The company has around 70,000 employees, net sales of over $12 billion US, and is headquartered in Kyoto, Japan. Regarding connectivity modules, Murata has over 20 years of experience in designing and manufacturing various wireless modules, from short range, such as Wi-Fi, Bluetooth, ultra-wideband, to long range, such as LoRa, Sigfox, and cellular modules, which I will explain more in details later on. We have 2 factories located in Japan and China, and a production capacity around 30 million modules per month. So Murata is the largest wireless module manufacturer in the world. This table shows most common wireless technologies that are typically used to develop smart connected IoT devices. Some important factors to consider to select the suitable technology include the power consumption, especially the device is battery operated, and the communication range, for instance, considering whether the device will operate indoor or can be located outdoor, will be stationary or mobile, or eventually operating autonomously in a remote area. And typically, the wireless technology can be split into the so-called short range, so the data has to reach a gateway up to a few tens of meters, let's say up to 100 meters. And then, so this can be the case for indoor application or wearable devices. While for the long range, it needs to send or receive a data up to several kilometers to the nearest gateway or base station. And for IoT devices, especially those are battery operated, need to operate on a low power consumption, then LPWA technologies are typically recommended. And finally, for applications making use of wireless devices that might be out of range of any of such terrestrial network, then satellite NTN, just introduced by Saitender, could offer an extension of the coverage outdoor. So this picture shows that actually terrestrial networks are covering a small part of the Earth's surface. We estimate around 15 to 20%, and those are mainly in urban areas, while suburban, rural, and cities may have limited or sometimes no terrestrial network coverage at all. And a smart wireless device embedding the Murata Type 1 SE module, that is a cellular plus non-terrestrial network, NTN hybrid module, will have the capability to connect to either the cellular networks in areas where those are available, so mainly urban area, and fall back on the satellite in areas with no or poor cellular network coverage, or eventually fully operate on the satellite network if this is required by the application. As mentioned by Saitender, from a hardware point of view, there's no modification to support NTN. This is the same in the Type 1 SE module. For instance, the same antenna that is already covering the cellular bands could be used. The only requirement is to upgrade the modem and the module firmware with the one supporting NTN. So the device then will be able to communicate with the satellite as long as it is located in an open space with a relatively clear line of sight to the sky. So that means the IoT devices using typically such cellular LPWA modules by a firmware update could add NTN capability and remain connected in areas with no or poor cellular network coverage. So for the same reason, the similar applications could benefit from NTN technology, including some the typically uncommon application leveraging LPWA in the smart city, for instance, smart meters, or to track vehicles such as cars, trucks, or even UAV, unmanned aerial vehicles, for disaster prevention such as flood, earthquake, environment and infrastructure monitoring, in the smart agriculture area such as cattle or crops monitoring, as well as all kinds of asset trackers or data loggers in remote areas, for instance, oil and gas platforms, mining fields to monitor critical assets, machines, and also improve the worker safety. This table shows a comparison of some of the common cellular and satellite protocols already available for IoT application, especially those those used by battery-operated devices with constraint on battery life, and using a simple hardware design that might be deployed across multiple regions. The combination of LTE CAT-M, NB-IoT, and NTN will be the ideal trade-off, especially using a single hybrid module, such as the Murata Type 1 SE. Additionally, power-saving modes, such as PSM and IndiRX, which are already available in LTE CAT-M and NB-IoT, are also applicable for NTN over NB-IoT. While some other legacy technologies, for instance, LTE CAT-M1 or other traditional satellites and proprietary protocol technology, can happen to be more power hungry, complex to design, costly in terms of the hardware implementation or the connectivity data plan, and eventually might require a specific SKU or face limitations to scale up when based on proprietary protocols, and making ultimately the deployment challenging for the end user. NTN over NB-IoT has been specified in release 17 of the 3DPP, which is the body responsible for cellular communication standardization. In order to offer standardized solutions, so by using especially the L-band 255 that operates around 1.6 gigahertz, and the S-band 256 that operates around 2 gigahertz. As mentioned by Setander, this is available for global deployment and allowing compatible cellular devices to directly communicate with satellites, so the so-called direct-to-device or DTD. I would like to briefly explain the steps to establish an NTN connection, especially with the 1SC module. In fact, the process is actually quite similar to attach to cellular networks. If you imagine the satellite as a relay in the sky, receiving signals from the devices on the ground and forwarding it back to the Earth to the ground stations. The main difference is a slight delay due to the signal propagation. The geostationary device being located in the sky, so for the signal to propagate back and forth, it takes around 500 milliseconds. And therefore, timing device or TA need to be estimated for the modem in order to communicate efficiently with the satellite. So for the user, this is actually transparent because the Type 1SC module will calculate this parameter automatically in the firmware, so making the NTN connection as smooth at the end as using the cellular networks. So lastly, to explain more in details about the Murata modules, first the Type 1SC that is using the Sony ALT 1250 modem And the next generation, the type 2GD, based on the also next generation of Sony chipset, ALT1350, have built-in capability to support both cellular and NTN. Both modules are suitable for global deployments, while the 2GD is even more optimized in terms of power consumption. The modules integrate an internal GNSS, an integrated eSIM, and also an internal MCU as options. Additionally, the 2GD bears additional or other features such as geolocation features for tracking, such as based on cell ID or Wi-Fi passive scanning, also support 15.4 protocols that are mainly used for metering. All you need to test the solution and to develop your next generation devices embedding cellular plus NTN connectivity will be to procure the Murata module kit. So the part number are indicated below. Feel free to reach out to Murata or distributors if you like to procure the kit. And besides, in order to test specifically NTN, you will need to have a compatible SIM card to insert in the kit, the SIM socket on the kit. So that's why I would like to pass it on now to Mao to explain more about Monogoto SIM card options, connectivity, data plans for cellular and non-terrestrial network. Mao, over to you.
Thank you very much. Thank you, Wenju. Thank you for hosting the webinar. My name is Mao. I'm the CTO and co-founder of Monogoto. Everyone talk about IoT. We are starting a pitch to move from IoT to software-defined connectivity. Monogoto established in 2018 as a connectivity service provider. We have millions of devices out there, and we understand that the ecosystem of devices or the market is changing. Different devices need different type of connectivity in different life cycle of the devices. A connected car can be sometime on high throughput, low latency connectivity, and later on maybe terrestrial connectivity, and when there is no coverage at all, satellite connectivity. Companies that want to develop new devices needs to be able to access different type of last mile. And with this in mind, we created a cloud with all the cloud best practice, but the cloud that we build is to serve enterprises with connectivity. So instead of going to the operators and get connectivity, enterprises can get the connectivity from Monogoto, and they can use API and self-service to define the connectivity. Maybe sometime on the satellite, sometime on the private, sometime on terrestrial, and sometime on different terrestrial, and all of this. As we know, when you make it right, you need to expose it with APIs and with self-service, because developer needs to consume it in that way. So with that in mind, we understand that maybe now we hear about connected car that needs satellite and cattle and others, but there are so many things you can do with global connectivity. And for us, we just want to help developer create beautiful product. And the way that we learn that innovation happen is by companies, cloud companies, mostly lowering the barrier. Lowering the barrier in terms of, I want one provider to be able to provide global connectivity, to be able to handle the security, to be able to handle the non-terrestrial network and the terrestrial network, to be able to help maybe with private networking and anything that we can do to make your life easier, less friction, and less time, so you can develop amazing product. With that in mind, we build a truly global network. And in the global network that we build, we don't discriminate between different last mile. The bread and butter, and this is how we started, is last mile over the terrestrial network, the public operators. We are global. We have global coverage: Australia, New Zealand, Southeast Asia, US, Europe, Africa, everywhere. On top of that, and for me, this is why we're here, and the real magic, we signed roaming agreement with Skyline. And when I went to Skylar offices to see the demo, and I saw a device with antenna this size that I'm holding in my hand can connect to a geostationary satellite, I was amazed. It's real magic, especially for someone like me that used to install 2.4 meters satellite antenna just to talk to a satellite. And for an enterprise to have a single service provider that can roam between satellite and terrestrial, this is a killer application. Mostly satellite use cases are not on. Sometime I will have terrestrial coverage, sometime I will have satellite. So for us, we don't discriminate. We understand that some customers will want only satellite connectivity. Other customers will want the satellite connectivity as a backup, and they will want the public connectivity. And other customers might also roam to a private 5G or private 4G, and we offer that on our cloud also. So we build one big network, and we allow different last mile. And for us, when the customer is managing it from one interface. Even the IP address that the device is receiving is not changing when the device is moving between the satellite and the terrestrial network or the private network. And we have a beautiful platform that the customer can connect with APIs to his platform. The customer can configure VPN, can download captures, can really we want to really make the life of the customer as easy as possible so you guys can focus in developing beautiful products. We are working very hard to add more and more APIs because we understand that you need to be able to define the way that the device should work, and you need to do it with less friction. So maybe I can help with steering between satellite or terrestrial. Maybe we can help with some campaign and automation. Maybe we can help with each customer might need 2 or 3 or 4 different APIs. We are very transparent. We are very open to allow you guys to consume traffic. And even to a situation that maybe your SIM card is not working for 6 months, so nobody will charge you. And then if the 6 months finish and the SIM card start to work, we don't expect anything special. The SIM card will be just built again. We really build a network for devices that needs connectivity, and it's less similar to the traditional network. We are investing a lot in documentation. In docs.monogoto.io, you can see how to set up the Murata kit. You can see how to do the AT command. You can watch a small video and really anything that can make the life of the developer easier and with less time and more success. The fun part. I want to share some pricing because lowering the barrier, meaning also making things more accessible. Satellite connectivity can start as less than $2 a month. You can pay $1 per month subscription fee, 30 cents per kilobyte, and you are good to go. Maybe you want to mix it with terrestrial. We can build package that will mix it with terrestrial. And this is amazing because when companies realize that it's not too expensive to jump on a satellite, it's not too expensive to have an annual or monthly package, now companies can really innovate. Now companies can really rely on connectivity, on cellular connectivity, on the use case, rather than try to build a LoRa network or try to build other networks. We believe that a network that is there and you're using it, it's much better than a customer that is needed to build a network. With that in mind, I just want to show you a picture of the dev kit that we are doing together with Murata. So yes, you can get the dev kit. You can get it also from us. You can get it also with a SIM card and with some data packages, just for you to have a single source of vendor to get going with your use case. Thank you very much for having me. This is my email if anybody have questions. Thank you.
Thank you, Mao. All right, so now let's move on to the demo session. 2 demos will be shown from Murata and Ritsu using the Type 1SC module evaluation kit. to connect to non-terrestrial network.
The Type 1 SC is able to communicate over Skylo's NTN network, and in this video, I will guide you on bringing up the Type 1 SC for NTN. Steps covered for the bring up would be, the physical setup for external GNSS, configuring the Type 1 SC for NTN and ping test, and sending UDP packet over NTN. When communicating over NTN, the challenge would be the need for UE to pre-compensate for the long propagation delay. It needs to estimate the timing advance, which is 2 times the delay from UE to a reference point. This is to ensure that the UE transmits ahead of time in order for the signal to reach the ENB at the requested time. There are 2 possible 1SC configurations with respect to position retrieval. In this bring up, I will go through the manual UE position configuration. Let's begin with the bring up. The first step is to carry out the physical setup for external GNSS. Go to Google Maps to get the latitude and longitude of the UE. Head over to dishpointer.com, key in the latitude and longitude. Then select the satellite. The Inmarsat 4F1 covers the entire ANZ, and the Inmarsat 4F2 covers Australia's west coast. Once position and satellite selected, press enter and scroll down. You'll then be able to retrieve the azimuth to position out antenna. Now we're ready to set up the Type 1 SC for NTN connectivity. Using AT commands, let's configure the Type 1 SC for NTN using manual GNSS position. For the purpose of testing, disable sleep mode. To switch from another RAT to NB-IoT NTN, multi-RAT is enabled, and then disable automatic RAT switch, which allows user to decide when to use NTN. Use of external GNSS is also configured. Now let's configure to auto connect mode, then set the band to 255. Then enable the NB-NTN RAT, and configure for external GNSS positioning. Let's configure to retrieve some URCs. They are useful to debug NTN connection. We first turn off the radio, then configure to receive SIB31, timing advance notifications, and the GNSS position request for manual position input. We also enable the RRC state and registration status notifications. We then configure proper APN and PDN type before starting the radio. Once position request URC given, provide the UE location. Wait for registration status to indicate SERIG 5. Once SERIG 5 is observed, it means the UE is registered to the network. Send the ping command to Google's public server IP. Here we see the echo from the ping, thus completing ping test. Let's now send UDP packets over NTN. Here I have a Google Cloud machine running my UDP server script. Now, we will use AT commands to first allocate the socket parameters, then activate the socket, and send hello world and hex to the server. Here, we see that the UDP server has received the hello world message, and has sent back an echo to the UE. Now the UE receives the echo from the UDP server and close the socket. We can now confirm that the UE has sent the message to the server and received the echo. Thank you for your time, and we have come to the end of the Bring Up guide.
NTN, or non-terrestrial networks, has been defined under 3GPP as an implementation mode of cellular communication network systems. With NTN technology, UE can now directly connect and link to satellite, even at remote areas, without direct coverage from terrestrial cellular networks. Unlike terrestrial base station, since NTN link is far apart, there is a large propagation delay and more significant Doppler shift during transmission and reception. When testing in lab, providing UE location information becomes necessary for the UE to compute and estimate the propagation delay and correct the Doppler shift. To test the GEO or HAP scenario where it has relatively fixed positional relationship between UE and satellite, we can use a GNSS simulator or manually provide location information through a T command to the UE. Next, let's take a look on a demonstration of NTN NB-IoT lab testing using Anritsu MT8821C and Murata 1SC module. Both Anritsu and Murata are certified Skylo's partner. Anritsu MT8821C is a cellular network call box that provides a convenient and controllable lab testing environment for your module before deploy to live network. This is the MT8821C GUI. Here you could set the frequency band and channel to be tested. In this example, band 255 is set. MT8821C supports multiple measurement items. Let's start with NP-RACH to test the module random access channel for registration. Click the single measurement button and activate the module. When the module sends out the NP-RACH message trying to register to the network, MT8821C will detect and capture the burst and display the results. By clicking on the Signaling tab, we could view the UE network status and signaling messages between the UE and the network. Here, the module is undergoing registration stage. Once authentication is completed, the module will be connected to the NTN NB-IoT network simulated by MT8821C. Due to longer propagation delay, it may take longer than normal terrestrial network registration to get connected. Once connected, we could go back to Measurement tab and measure the fundamental RF parameters such as transmit power, OBW, SEM, ACLR, EVM, and throughput. These parameters are essential as the device has to comply with 3GPP specifications for interoperability. Throughput is related to RX sensitivity, which is an important factor for NTN device performance due to lower signals received from satellite. Anritsu also provide Automation Test Tool ATS to automate the test cases in accordance to 3GPP specifications and some R&D test items. ATS allows different type of DUT control, such as serial port, ADB interface, and etc. Next, we shall start by defining test plan on what frequency band, channels, and test cases need to be tested. When click on the test case, the right panel will display the test parameters, conditions, and pass or fail criteria. You can click on Enable all test items to apply all applicable test cases and deselect test cases that you do not want to execute. Once done, you can save the test plan. Next, open ATS UI, load the test plan and click Run button. ATS tool will control your device, including reset and get it ready to register to the MT8821C NTN simulated network. Once connected, ATS tool will start execute the test cases as defined in the test plan created. Let's fast forward the test. When the test completed on the GUI, you will get a quick glance of the pass or fail status, total test time, total test cases, and individual test items and its results. ATS is also capable of generating reports in TXT, CSV, and PDF format. This concludes the demonstration of Anritsu MT8821C testing of NTN NB-IoT module. Enritsu offers 3GPP NTN test solution for both RF and protocol, from development to conformance testing, including carrier acceptance test for Skylo. Please feel free to reach out to Enritsu to further understand on how we could help you to test your new NTN device in lab before deploy to live network. Thank you for watching.
All right. So let's move on to the Q&A session. You can still post your question in the panel located at the bottom of your screen. We already received a few questions from the attendees, so I will start to read it one by one. So for the first question is related to the demo we just watched. So for the 1SC demo, the EVK was configured to retrieve GNSS position externally. How different would the commands or operation be if it was to be configured using the internal GNSS? I think maybe Murata, Jan, who is our application engineer who made the demo, would you like to take this question?
Hi, sure. So for the 1SC, configuring to use the internal GNSS requires slight changes in the commands, specifically to enable the internal location services and to set the NTN configuration to utilize the location provided by the onboard GNSS. Operation-wise, the device will require getting a fix on initiation or whenever SIB31 or position expires. The position is estimated using the iGNSS, which takes roughly 30 to 60 seconds. And once the device provides this information, the modem can proceed to attach to the network. Yep.
Thank you, Jan. Let me take the second question. It's also related to the demo, the one by Enritsu. Which RF test is the most challenging for NTN NB-IoT compliance? And is OTA TRP TIS testing important for NTN devices? So I would like to let maybe Vunyan take this question. Vunyan?
For the question. Okay. So for the RF test parameter, because now that we are need to connect to the satellite, which is far apart between the terminal and to the gateway and the base station. So the path loss is significant. Then the sensitivity, we need to really have a very good sensitivity on the device in order to get the signals from the satellite. So yeah, on the lab, you will need to do the thorough testing for the sensitivity of your device in order to get a good connections to the NTN network. And while on the module, so usually we do the testing using the conducted method, but the actual performance will be affected by the antenna that implemented on your device. So that is why the TRP or TIS is absolutely essential to be evaluated in your end device form factors. So yeah, so it will be necessary to do the TRP and TIS as well to know how good your device performance is. I hope this answers the question.
Yeah, thank you, Vunyan.
Thank you.
We received quite a lot of questions. Let me go to the next one. So, is the spectrum used for NTN communication license? Does Skylo use LEO, MEO, or geostationary satellites? Or Satender, would you like to briefly take this one?
Yes. So the spectrum, what we have today or what we are using today is leveraged from the existing geo satellite partners. It's called a MSS spectrum. So it's licensed, and we use geostationary satellite today. I hope that answers.
Yep.
Yeah.
Next question, can we switch automatically between TN and NTN? What is the minimum payload or frame size, and how does the billing is calculated? Is there a minimal data usage for using NTN? I think that will be a question for Monogoto Mao.
Yeah, I can take it. So on the NTN, the minimal payload is UDP, and Skylo support mainly NB-IoT over LP, at least with the roaming operator. So the minimal payload that Skylo bill us is 50 bytes. So it's a little bit more than the UDP headers plus some payload. If the payload is less than 50 bytes, we will round the CDR to 50 bytes. That was the question, correct? What was the second part of the question? I'm sorry. Switching the network. Yeah.
Yes, I think for the switching.
At the moment, you need 80 command to switch the between NTN to TN. We expect in the future, together with Murata, to make it more seamless and even to do it from the network steering. But at the moment, it's with 80 command.
Correct. It's managed in the module firmware side.
Correct.
So next question, what is the energy consumption for NTN communication? What kind of battery is needed to power the radio device? So I can actually take this question. So basically for NTN communication is comparable to cellular. The reason is the hardware is the same. The module, the antenna, and besides, and of course, NTN is using NB-IoT, so which is the same, specified the same way for cellular communications. So that's why typically for cellular communication, we would expect during the transmission phase, a very short peak current that the battery need to supply of the order of magnitude of several hundreds of milliamp. So typically, the application served by LTE CAT-M or NB-IoT can have a battery life or can require a battery life of several years, up to 10 years or more. So we would expect that NTN will be compliant as well with this type of battery life. Let me go to the next question. I think it was partially addressed by Setander, so but I will ask it again. So when Asia regions will have the NTN coverage?
Yeah, so I answered that, but typically if you look at Asia, we do have coverage over Australia, New Zealand, Japan. Taiwan also, we have beams there. We are looking at providing Southeast Asia as soon as possible, but as I mentioned, it's not a function of technical challenges what we have, it's a function of demand. The moment we have a substantial demand or a substantial forecast, we will prioritize that particular geography.
Thank you, Setander. So next question also related to Skylo, but we can help to answer it, is related to the antenna. So do we have any experience using the printed antennas from Skylo? Maybe I can give a little bit of background. So of course, for the antenna portion, it's up to the end device, maybe to the space available in the device, and if the antenna need to be embedded or can be external. The one shown by Mao earlier in the presentation is a stick antenna, so the size may be around 10 centimeters or more. This is the same antenna that we recommend to test with our module evaluation kit. Alternately, I believe a PCB printed antenna can be working as well. And regarding the printed antenna that is mentioned in the question, Setander, do you have any idea? Are you recommended any printed antenna?
I don't think we have tested with the printed antenna, but if you look at, if you go to our website, we have a device conformance document, which talks about the bare minimum requirement of TIS and TRP of an antenna. And if that meets, I think that should be good enough for you to connect to satellite.
Thank you. And one last type of antenna that we tested actually with our module and can provide the test report is a chip antenna. So it's working fine as well for both cellular, terrestrial, and non-terrestrial network communication. Just give me a while, I'm going through the questions. This question is maybe a bit technical, but maybe Seitander or Maor could address it. Do you have any plan to use regenerative mode NTN rather than transparent mode? Seitander or Maor, do you?
That's not for me. This is for Skylar.
Okay.
Whatever Skylar will give us, we will be able to resell to the customer, guys.
I think we are still looking into that, but whenever we have it, we'll announce it to the world.
And next question also for you, Seitander. You partially reply, but maybe can provide more information.
Mm-hmm.
What is the latency for Skylar network? Maybe if you can help to break down.
So we are looking at average latency of 10 to 15 seconds. But it all depends on how the device is installed and where exactly it is located. But average latency is 10 to 15 seconds.
Correct. And I will maybe to add is probably more related to the backend side. So in terms of the signal propagation, actually the latency is very short, even if the satellite is located in the sky around 36,000 kilometers. But the time to travel back and forth is only 500 milliseconds. So it's more in terms of the latency is more related to the back end, I would say. Next question is for Monogoto Maor. Does Monogoto development kit support non-IP? I think this is the picture you show in your presentation.
Yeah, it supports non-IP as the kit. The problem is that most operators don't allow the non-IP traffic. Even Skylo only allow the IP on the roaming partners. So theoretically, yes, but practically in Europe, North America, and Australia, our kit will be NB-IoT over IP.
Oh, thank you. Our next question is quite interesting.
Or CAT-M.
Oh, all right. Our next question is quite interesting. So it might relate to the demo that we showed in the earlier. So does the antenna need to be aligned with a certain azimuth for NTN communications? And how does this work for mobile platforms? So maybe I will ask Jan to assist me to answer, just to give a little bit of background. Of course, the antenna, it depends on the type of antenna. Some antennas, I would say, can radiate in all directions. Some antenna are optimized to radiate in a specific direction, such as the directional antenna. So I would say, of course, for our testing and to be able to get the best performance, it can help to direct the maximum gains to the expected location of the satellite. That's why we, in the demonstration, we showed the azimuth. Jan, would you like to complement based on the test on the demo that you conducted?
Yes. Okay. So regarding this question on the azimuth, so initially when I was in Melbourne doing the test, I did test by aligning my antenna in another direction as opposed to the correct azimuth of the Inmarsat satellite in that will be beaming on Melbourne. Yeah, and I was still able to carry out my test and connection. So regarding the question on how it would apply on mobile platforms, right? I would say that first of all, there are quite a number of factors when it comes down to this, like line of sight with the satellite. And the recommendation is to set up a system where we could face the satellite within your location. But if that is not possible, then I think connectivity is still possible. Connectivity is still possible even if we don't point the antenna directly at the satellite. However, when we want to talk about reliability and quality of the connection, it is still preferred to be pointing at the satellite. So, yeah.
Sorry, I was muted. Thank you, Jan. I was going through the question, so I would like to ask this one. Is the 1SC satellite, is the 1SC module satellite agnostic? For instance, can it work with multiple satellite providers, or some kind of update to the module will be required? So basically, I don't have a complete answer to this question, but I think it's quite interesting. And probably Satender could help to complement. So, so this NTN technology is specified in 3GPP. It means that it is a standard, and in principle, as long as the module firmware follow the standards, then it should ensure some interoperability. I understand the Skylo solution has the possibility to work with several types of satellites. And of course, our module will be compliant as long as we pass the certification. So maybe, Satender, would you like to elaborate a bit more about this question?
Yes. So if you look at Murata 1SC, and if the module and if the dev kit is certified on band 23, 255, and 256, we have multiple satellite partners in different geographies. And devices can, basically you won't even know that if the device is connecting to a satellite partner which is in Australia versus a device partner or a satellite partner who is in Europe, right? So if it's certified to a specific, all the three frequencies, it should be able to connect to different satellite partners.
All right. I think due to time constraint, we have to end the Q&A session now, but we will answer the remaining questions, actually quite a lot, and some are really technical. So we'll answer in the recap page that will be available in a few days together with the webinar recording on demand. That's all for today's question and answer session. If you are interested in the solutions presented today, feel free to contact us. So this is our contact person for each company, and we'll be happy to offer support for your projects and answer your questions. So we have come to the end of the webinar. If you enjoyed it, please subscribe to Murata Speaks webinar series to receive the updates on the topics for upcoming webinars and first-hand information on Murata's exciting technology and solutions. Once again, we would like to thank all the participants, and we look forward to seeing you soon again in the next webinar. Bye.